Hello and welcome back. So in the previous video I went through a brief overview of my solar panel power station or power system, whatever you want to call it. So now I want to go into something in a bit more depth, and that is the way I control solar. And I've created a little system and I'm going to explain it. So basically what I've done is I've come to the conclusion that solar really needs something to control it, and the reason being is if you've got batteries, you just have solar on and on and on and on and expect that there's going to be solar power available, or in other words there's sun available, because it doesn't work like that. And you can't really drain these batteries through the night, because with lead acid batteries you don't want to drain them, you want to use them as a buffer really, because if you start draining them and draining huge amounts, you start damaging them. So yeah, use the batteries as a buffer. Now, because you need to use batteries as a buffer, it presents a problem, and the problem is, how do you know when to turn it on? How do you know when to turn it off? And so I've made a solar controller, or a solar, I don't know, I call it AI or artificial intelligence, but solar controller. So now this is my solar controller. I'll just show it you quickly and then I'll explain. Okay, it's looking a little bit of a mess really, but this is just how far I've got. So these boards here make up my solar controller, and I'll just zoom in so you can see them a bit better. There's stage 1 if you like, stage 2, stage 3, and there's the display. And I'll show you these on in a minute, but for now I'll just go back to the paper and I'll carry on explaining. But basically this is my charge, well, not a charger, it's this is my AI or solar controller if you like. So now I'll just explain, I'll just push this to a side for now and explain, what this is. So back to the paper. What I wanted to do is to analyse the data from my solar panel system so that I could learn more about it and so that I could control it more effectively. So in order to learn more about it, I needed to log some data. So I needed to log data. In order to log the data, I needed to get the data, and then after that, of course, I need to analyse it. Now at the same time, I can use this analysed data to do things like, I don't know, switch the inverter on, switch it off, switch over to mains, switch back to solar. With this data I can do a lot of things, and therefore I can create an artificial intelligence system to switch things on and off for me. So I've spent quite some time on this, and this is how it works. Now I've got sensors. So I've got a battery voltage sensor, which is a voltage divider, but so I've got a battery voltage sensor, a battery amperage sensor, which is how much current is being drawn from the batteries, solar voltage, so the voltage of the solar coming in, solar amperage to find out the amount of current that's coming in. I've got the load voltage, which will be 250 volts or thereby, load amperage to find out how much is being drawn from solar, no, not solar actually, from the inverter, and I've got a light sensor. So with all these sensors I can get all of that data. Now I've got a sampler here, and the sampler samples all of these several hundred times per second. Well, actually I don't know if it's several hundred, but a lot of times per second, and it averages them out over a 30-second time space. So the sampler gets samples, averages them out, and every 30 seconds it sends them over to the solar controller. So the solar controller then controls two things. It controls the contactor to decide whether we use mains or solar, and it controls the inverter, which obviously turn the inverter on or off. But I've gone a step further. I've got a display, it's CFT of course, I've also I'm a programmer by trade, so I've also programmed a service on my server, and the service basically gets this data. The data's like this. It's sort of like solar voltage, amperage, battery voltage, etc., and it ends in a semicolon. These strings of data, which get sent from the sampler to the solar controller, also get sent to my server service, and the service sends them and saves them into an SQL database. So these strings of text here get saved into a database, and that means that I can analyse their data. So not only can I analyse it, I've also created quite a basic website really. I've created this website, and the website reads the data from the SQL database. The website also has some controls to send commands back to the solar controller. So the website's got some buttons to send data back to the service, and the service then sends data back to my house, and specifically to the solar controller. And the solar controller can then do different things like switch on, manually switch something on, manually switch this off, etc. And that's a summary of the whole system. So now I'll go in a bit more depth and tell you exactly what's what. So to start with, the sensors. Now I'm not going to go into the sensors in too much depth in this video, but suffice to say, they're very basic sensors. The voltage ones are voltage dividers. So they're voltage dividers, this one, this one, this one. And in fact the light one is a voltage divider. It's based on an LDR. The amperage ones are ACS units. There's an ACS 712, in fact there are two of those, and there's an ACS 758. And they're current sensors. So that's all I'm going to say about the sensors. But going on, the sampler, this is the sampler here, and it's an Arduino Nano. I'll just zoom in a bit more now. Yeah, it's an Arduino Nano, and this basically samples all the sensors, and the sensors get plugged into these here, where it says A0, A1, A2, A3, A4, A5, A6, A7. And there's a special algorithm which the solar controller uses. So I've got two plugged in here, only two sensors out of several. I'll explain that in a second. But that's the sampler anyway. So these here are for the to supply voltage to the actual sensors, and these are for the signals for the sensors. I mean, this here is just something for testing, but anyway. So that's the sampler, I call it. Now you can see here that I've got two sliders plugged into this thing. That's because I'm using some artificial sensors, and of course these are artificial sensors, they're sliders, and more on that in a second. So now let's zoom out a bit more. So from the sampler, I'm supplying something to a node MCU, and I'm supplying 5 volts, a signal, and ground, 0 volts. So the signal is this arrow here, and that's basically serial data. So it's sending serial data, which is these strings of text are sent via serial to this every 30 seconds. And this is the solar controller. So the solar controller basically controls the contactor and the inverter. And for now I've just put these two here. One LED represents the contactor and one LED represents the inverter. Really though, these would be, the signal or the voltage will be going to a MOSFET, and the MOSFET would be switching this on or off, or a relay or something like that. So that's what those two are. Now, the solar controller, it's quite advanced. It's taken me a while to write, but the algorithm is quite simple, really. And the algorithm is, now I mentioned about these two sliders. The algorithm is, of all of the sensor values, the most important ones to me are battery voltage and light. Now, this is just my way of doing it. That's what, that's the way I found to be best. And it uses those two values, which have been sent by the sampler, to decide whether these two should be on or off. And I use thresholds. So if these are both over a threshold, turn solar on. If both of them are not over a threshold, then turn these off and go back to mains. And that's how that works. And here you can see that it goes to a TFT. I'm going to turn this on in a minute and show you. But the TFT is just wired up in a normal way. So the server service, the website and the SQL database, I'll show you that in a bit. But anyway, for now I'm going to show you this thing working. Okay, so I'll just, now is a good time to show you about this power module. You can see here it says power module, and that is this. It's basically a switching power supply chip, basically. Just zoom in on that. It's basically a step down transformer, because my batteries are 24 volts, but this whole system runs off 5 volts. So that's a step down. I think it's called a buck converter, and I've just set that to output 5 volts. So anyway, I'm going to give it some power now. Some well, you can say artificial power. It's from a power supply unit. So I'll give this, I don't need to go too mad. I'll just give it, 11 volts or something like that. Then reset this. And you can see that it started beeping. I've got a little buzzer in there. So this is powering everything. This is sampling the sensors, which the two important ones which I've mentioned are over here on the sliders for the time being. This is making the decisions. You can see that the two LEDs are off. That's because it's decided that it wants the contact and the inverter to both be off. And over here there's some output. Now I'll zoom in on the output so you can see what it's saying to me. So it's saying, of course there are no sensors plugged in, so this is going to be rubbish data, but just to show you. So solar voltage, solar amperage, battery voltage, amperage, load, etc., light. Now if I go to these sliders, and in fact I'll bring them closer. Bring these a bit closer. Right. Now you see that light value and the battery voltage. I'm going to slide these over now, just maybe halfway. These have all been preset, by the way, to calculate certain values. If I just slide those halfway, you can see that it's changing. So battery voltage 3.2 and light 1700. In a minute they'll see this is smoothing out. The sampler smooths out over 30 seconds. So this could take, up to, I don't know, a minute or so for it to sort itself out. Now when voltage goes to a certain amount, it's going to switch everything on, so I'll just put this into view as well. Now I'm going to make the battery voltage and light full, so look what will happen now. Again, it smooths it out, so it could take around about 30 seconds. And it's decided that it should be turned on, so you can see the LEDs. And now if I put one of them down, I don't know which one I put down there, whether it's light or something, but you'll see that it'll now switch solar off after an amount of seconds. There we go. So I've just turned the light off. Basically, I'll turn it right off. Turn it off to 0. In fact, I might as well I'll put battery voltage on about half. So battery voltage should probably go down to about 15 now, roughly. Here you go, 21. And I'll put light maybe halfway. I measure light up to 5,000 units. And there we go. And that's a very quick overview of my solar controller, if you want to call it that. So I've got to go over the programming or computer-based stuff, which is here, the server service, the SQL database and the website. I'll show you that soon as well. Okay, so I hope you enjoyed the video and thank you for watching. Bye!